Now, we discovered that the solution to the ghost problem was not that we got rid of the ghost. We never got rid of the ghost. We just showed that the reasoning that caused you to think there was a ghost was not valid.
Right.
I mean, everybody that was trying to get rid of ghosts was adding on terms that would cancel something, but you never needed to do that because it was never, the reasoning was wrong. And what, of course, how does it work, is instead of having vacuum T55 vacuum, the left vacuum has to be the PT conjugate of the right vacuum and not the Hermitian conjugate. And then when you put in intermediate states, it's no longer modular squared, and therefore you can get a minus sign. I mean, those are the details, but the basic point was, and the thing that saves the theory, is that the states were not normalizable. Now, Carl had developed a whole apparatus for dealing with non-normalizable states, namely, there was a way to continue them into the complex plane. So if you had something that went like e to the plus x squared on the real axis, it went like e to the minus x squared on the imaginary axis. And so this theory lives on the imaginary axis. And of course, people were trying to do quantum gravity with everything living on the real axis. And that's, in my opinion, why they couldn't succeed. So that was the first side of the story, was the PT. Now, the second side of the story, and I realized this as soon as I got to know about PT, was that there was a connection to CPT. And the CPT goes the following. The Lorentz group breaks up into 4 units, 4 regions. There's the one with the real coordinates. Then there's the one which is related by parity, one which is related by time reversal, and one which is related by parity times time reversal, which is PT. Now, parity reverses the spatial piece. Time reversal reverses the time piece. So PT reverses all 4 components of x mu. And that's Lorentz. That's consistent with Lorentz. And so what you discover is that there's an extension of the Lorentz group which involves a PT transformation into this other region where x mu is replaced by minus x mu. And that turns out to be the covering group of the Lorentz group. And so if you have that as a symmetry, then Carl said, look, PT is natural. It's related to the Lorentz group. Hermiticity is an artificial requirement on a function. It's a mathematical requirement. Symmetry of a Lorentz group is a physical requirement.
So you get Weyl spinors out of this?
Not yet, almost. So that's PT. Now you do it you did it for coordinates. Now you do it for fermions. So I did it for fermions. Didn't work. The reason is, for fermions, P is gamma 0, and T is gamma 1, gamma 3. But gamma 0, gamma 1, gamma 3 is not a Lorentz invariant. You have to multiply by gamma 2. Gamma 0, gamma 1, gamma 3, gamma 2 is commonly called gamma 5, is a Lorentz invariant. But gamma 2 is charge conjugation. So for fermions, that transformation is CPT, not PT. And so what I'd realized was that CPT symmetry was intricately connected to the complex Lorentz group. And so if the universe is complex Lorentz invariant, then CPT can follow. And then if C is conserved, then you're back down to PT, which is what you get for the non-relativistic case. However, that's not the whole story. And the reason is, if I write down something like psi bar psi, which is a Lorentz scalar, it's a CPT invariant, but it's now got a coefficient. How do I make the coefficient is going to be conjugated by time reversal? So it may not be real. So can I make the coefficient real? And the answer is yes, if I impose probability conservation. And so I replace the entire discussion of CPT theorem by complex Lorentz invariance plus probability conservation gives me CPT.
Curt here. Note that if you'd rather listen to Toe, We're on Spotify, iTunes, everywhere with a podcast catcher. You can just search my name or Theories of Everything. And also, remember to hit subscribe.
Now, any non-relativistic theory that descends from relativity would automatically have probability conservation. And if you have a non-Hermitian Hamiltonian, you need to have the CPT conjugate be the bra, not the Hermitian conjugate, and then probability is conserved. So the key feature, and I think this is what people have missed, the key feature of quantum mechanics is not hermiticity, it's probability conservation. Hermiticity implies probability conservation, but probability conservation does not imply hermiticity any more than hermiticity implies reality, but reality of eigenvalues doesn't imply hermiticity. So probability conservation is, in my opinion, the most important feature of the theory. And that's how the PT works. Okay, now, as soon as I started to work with Carl, we solved the problem of the ghost. And now I can tell you why it's guaranteed that this is the solution. You take the fermion and you couple it to geometry through the spin connection, which is how we describe the propagation of spin-and-a-half particles in a gravitational field. You take the action psi bar I gamma mu d mu plus capital gamma mu psi. That's the coupling of a Dirac fermion to the spin connection. And you do the path integral over psi and psi bar. You get the c-squared action. You've integrated out the fermions. The only thing that's left is the metric, and the metric appears as c-squared. Why is it c-squared? Because the Dirac action was conformal invariant with the spin connection. So it was already conformal, and therefore you automatically get the c-squared action. So now you've only got two arguments. There are only two things you can say. Either we know the standard theory doesn't have a ghost. Therefore, the gravity theory could not have one if it's induced by integrating out the fermions. But if it did, then the entire SU3 cross SU2 cross U1 would collapse when it's coupled to gravity. So you've only got two choices. Either there's no ghost, or SU3 cross SU2 cross U1 is wrong. And there's no reason for a ghost, because you're starting out in a theory which is ghost-free, the standard model, and you just integrate out the fermions. So in the end, there could never have been a ghost in the first place. But how do you show that there's no ghost? You've got to construct the Hilbert space and get the bras. The bras are called the dual space. And the whole point of these theories is that the dual space does not have to be the Hermitian conjugate of the cats. Physics is richer than quantum mechanics is richer than that, and that I think is what Carl has really established: is quantum mechanics does not require the dual space to be the Hermitian conjugate, the same way that Dirac originally introduced it. It's a richer theory, and it's that richer theory which works in the fourth order case.